Hi, in this video we're going to focus on angle bisectors in triangles. But first we're going to review real quick angle bisectors. Remember, an angle bisector is an angle that divides an angle, is something that divides an angle into two equal halves. So you'll have two congruent equal angles. Okay? In other words, the angle bisector is equidistant from each side of the angle. Okay? So if I were going to take this angle and I wanted to make the angle bisector, I first have to know how big the angle is so that I can divide that in half. So I'm going to measure the angle. Okay, so when I line this up, I can see that I have a 50-degree angle. Let's review that real quick. Okay, so I lined up with the center out towards the right along the bottom line on the protractor. And then I have two numbers when I come out this side. I have a 50 and a 130. I know it's the 50 because that is the set of numbers that starts at 0. This one starts at the 180 and works backwards. We want to count up as we open up that angle to 50. So I know this is a 50-degree angle. Okay? All right, so now if I want to bisect this 50-degree angle, I'm just going to divide 50 in half, and so that's going to be 25 degrees. So I'm going to line my protractor right back up, and I'm going to measure 25 degrees. So 0, 10, 20, 30. It's going to be this line right here in the middle, 25 degrees. Okay? So then once I make my dot at 25 degrees, I can use a ruler or a straight edge and sketch my line. So now I know this is an angle bisector. Okay? And I have 25 degrees here, and I have 25 degrees here. Okay. Now, when it says above that it says the angle bisector is equidistant from each side, remember distance to a side is going to be perpendicular. It's the perpendicular distance. Okay. So if I want to figure out a perpendicular distance from a point on the angle bisector to the side, here's what I have to do when it's not on a graph. If it was a graph, I could use my opposite reciprocal slopes, but this is a little bit more interesting. If I pick a point somewhere here on the graph or on the line, okay, and then I want it to figure out how far is this point from this ray, I have to measure it going perpendicular, and I want to make sure that I really do measure it perpendicular. So instinctively, we tend to want to put it here and then measure out perpendicular from that point. However, it's going to make I want the 90-degree angle to be on this line. I want to hit this line at a perpendicular angle. Okay? So instead what I'm going to do is I'm going to take my protractor and I'm going to look at I'm going to slide it along this ray, and I'm going to watch for when this 90-degree line intersects that point that I put on the angle bisector. So I'm just going to slide it till it intersects that point. And then I'm going to make sure it's nice and lined up through that point. I'm just making sure it lines up with the 0 and the 0. And then it comes up to 90 degrees through that point. And that's going to guarantee, when I put this dot over here at 90, and then I line these two dots up, I'm just trying to make a 90-degree angle. Okay, so I end up here with a 90-degree angle. Okay, and then I'm going to do the same thing from this point with this side. So instead I'm going to line the protractor up with this side, and when this line that goes up to 90 goes through that point, that's where I'm going to stop. Okay, and then I'm just going to make sure that I'm lined up both sides along the line that matches up. And I'm going to come up here and put a dot at the 90. So that way I can line up these two. And make my 90-degree angle. Okay, so those two segments are equidistant. This point I'm saying is equidistant to the two lines. If I were to take a ruler and measure, I can see that this one is about 1.8, right? It's not quite all the way to the 2. It's about 1.8 centimeters. And if I measure this other side, I also get, I'm right there at 1.8. So these are both exactly the same length. So this point is equidistant to both sides. And it doesn't matter where I picked the point. I could have picked a point anywhere along this angle bisector. I could have put it way out here and done the same thing, lined up until that 90 went through that point, and then found my 90-degree angle, and done the same thing to the other side till I went through that point and found the 90-degree angle. So again, these are the perpendicular distances, and these are going to be the same length. Okay, so no matter where I pick a point on this line, it's going to be the same distance perpendicularly to each side. Okay? All right, the next thing we're going to do in the next video is we're going to go back to, remember our triangle parts reference guide that we've already been filling out the past 2 lessons, where we looked at our altitudes in each triangle and the location of the intersection. The orthocenter was inside for an acute triangle, on the right angle for a right triangle, and outside my triangle for an obtuse triangle. And then we looked at the intersection of the medians, which we call the centroid, the balancing point of the triangle, and it's always inside. I like to think of that as the centrist center of all these centers that we're going to learn. Okay, so we are going to do another center today, and for that one, we are going to look at the angle bisectors and see where they intersect on the triangle. Okay? Thank you so much for watching, and I'll see you in the next video.